Hi, I'm Jim Woljenski, Principal Database Engineer at AWS. Today we're going to talk about optimizing Postgres on AWS. So why are people using Postgres? Postgres has a very long, rich history in its development. It started back in 1986 as a University of California in Berkeley project that turned into an open source project in 1996. One of the key things about the Postgres project, it's not owned by a single company. It's owned by a foundation. So this way, things are driven by a community model and new features are added not with a single customer in mind, but with a whole community looking at things in a very global mindset. And because of the Postgres license being a very permissive license based off the BSD license, a number of commercial entities have forked Postgres over the years and created their own derivatives of Postgres over the years, and also have used it extensively in their organizations with no fear of any sort of open source licensing along the way. Postgres was built with performance in mind. With having very complex query support. So this way you're able to have everything from your simple OLTP databases up to your larger relational and data warehouses running on Postgres. It has an extensive index support. So instead of just having simple B-tree indexes, you have a number of other indexes that allow you to do things like full text search and geospatial, in addition to having more advanced features like parallel query and native partitioning. Postgres is also a very inclusive community of looking across a broad language support. So if your application is written in everything from Python or Java or .NET, Postgres has a driver that connect to it. And one of the unique things about Postgres, it allows you to write your server-side code, your stored procedures and your triggers in multiple different languages. In addition to its native stored procedure language, pgSQL, which is very similar to Oracle's PL/SQL, you could also write your stored procedures in other languages like Perl or JavaScript. It also is very feature-rich on more advanced functionality, like the geospatial functionality set. So this way you could do things like near neighbor searches and doing routing for your mapping applications, all within Postgres itself. So how are people running Postgres in AWS? There's a number of people who are doing it in a self-managed environment inside of EC2, and they're very much a DIY type of crowd, but there's a large number of people doing things in a managed environment with the RDS Postgres and Aurora with Postgres compatibility. That gives you a lot of extra capabilities on top of self-managed and makes it easier. And those are some of the topics that we're going to talk about today. So when you're choosing your Postgres deployment, there's definitely a continuum of how you're going to deploy Postgres. You may have a simple environment where your database server can be co-located with your application server, and you're running everything on a single instance. But as you're starting to scale and your applications get bigger, you may have a self-managed database server itself. So this way it's have an instance size and an instance IOPS that are dedicated for your Postgres database, which may not apply directly to your application servers. But as you moved into the managed environment, you have RDS Postgres, so it is a Postgres environment that is completely managed by AWS and be able to take advantage of the RDS infrastructure in order to make some of your tasks simpler and you could focus more on your business. And as you scale out and you want high availability, you move into the Aurora with Postgres compatibility in order to be able to take advantage of the next generation cloud storage architecture for your relational database. So starting first with RDS for Postgres, RDS for Postgres comes in a number of different versions based off of the Postgres community releases. So the Postgres community puts out yearly major releases and quarterly minor releases, and we keep up with the latest release versions coming out of Postgres. Postgres release cycle is something of an unusual release numbering cycle up until release 10 that came out last September. Before that, the major releases were actually at the dot release. So 9.6 is a different major release from 9.5, different major release from 9.4. So we have 5 major releases in RDS Postgres. Also new is our new release and preview environment for Postgres 11. Postgres 11 will be released by the communities in the September timeframe. There's a large number of new features in there that people want to be able to take advantage of and start testing for their application now. So this way, when it's released out in the coming months, they've already tested it and see the advantages of the new features. RDS allows you to be able to test that without going through the build process of Postgres in order to be able to get the source code, build it, run it in your environment. With the preview environment, with just a few clicks, you're able to get that preview environment up and going using the latest beta releases of Postgres with Postgres 11. You can see that at aws.amazon.com/RDS/database preview. As we're talking about a continuum of the offerings of Postgres from AWS, we get to Amazon Aurora. Aurora is a cloud-native relational database engine with Postgres compatibility on top. So your applications work seamlessly with Aurora and being able to take advantage of the cloud architectures underneath. So you see things like 2 to 3 times better performance for some workloads on Postgres using Amazon Aurora. You're able to take advantage of automatic scale of your storage, so you don't have to pre-provision mount points in order to be able to guess how much storage you're going to be able to take advantage of. It'll automatically scale up to 64 terabytes. Plus, it's built from the ground up being highly available and fault tolerant, of having your data replicated across 6 individual storage nodes across 3 availability zones. So your data is always secure and ready and available for yourself, leveraging the transparent encryption. Additionally, having that shared storage layer, you're able to take advantage of read replicas that spin up in seconds as opposed to minutes or even hours for large database instances. Because of that shared storage, everybody's pointing to the same storage nodes. We'll get into more detail about Amazon Aurora in some of the coming slides. So how do we optimize Postgres in an AWS environment? We're going to talk through several tasks that a normal administrator or operator will have to work through in order to get Postgres set up for a production environment. And how can AWS help you in order to get there faster and be able to leverage things in your environment quicker? So the first task whenever you're setting up a new production environment is just setting up Postgres. You'll need to create a server instance. So if you were setting up an EC2 instance, you'd start up whatever instance size you'd like, but then you'd have to go ahead and install Postgres. So you might use the Yum repositories in order to be able to do that. That goes fairly fast compared to some of the commercial databases where that install step may take a few seconds to a few minutes in order to be able to install that. And then creating a database instance by running the Postgres command initdb in order to give you your data directory. Where the real time comes into play of configuring your Postgres instance. The PostgreSQL.conf file, like a lot of other databases, have many options there in order to be able to tune for the server that you're running on. The PostgreSQL.conf file has over 250 different parameters that are on there. So being able to tune that for your instance size can take some time, especially if you're not familiar with Postgres enough in order to be able to know which parameters to tune. One of the best optimizations of using RDS Postgres is being able to take advantage of the default parameter groups inside from RDS. So when you're starting up an RDS Postgres instance, you choose your instance size, which may be based off the amount of memory and the number of cores that you need for you're anticipating for your database needs. And the default parameter groups will automatically tune your Postgres database based on your instance size. So when you want to set up your shared buffers, which is your database cache inside of Postgres, you don't have to guess at what that parameter means. The default parameter groups are automatically going to scale that based off your instance type. So this way, as you're learning Postgres and you're becoming more familiar with Postgres, the default parameter groups is a great way to get immediate performance out of Postgres that you would normally not get trying to tune on your own as you're learning Postgres. The defaults inside of Postgres, when you use the Yum repository settings, your main database cache of shared buffers to 128 meg. Whereas the default parameter groups inside of for RDS Postgres is going to set that to a more reasonable number of 25% of your system memory. You'll see that immediately from performance as you're being able to run on RDS Postgres compared to running it on your own if you haven't configured those sort of things. Another thing is doing automatic maintenance. So Postgres coming out with those quarter releases, will having to do those patches, you have to do that on your own. And it's definitely advised to keep up with those quarterly patches inside of Postgres. There's some bug fixes, there's some security fixes in there, sometimes some performance improvements. You want to be able to leverage those things. So the automatic upgrades during your maintenance windows is something that you want to take advantage of. Once you have a database and you're running this in production, the first thing that you want to do is set up your backups. You're putting all your mission-critical company's data inside of a database. You want to have that backed up. So when you're doing that, the first thing you have to do is figure out where you're going to store it. If you have a 1 terabyte database, where are you going to put those backups? One of the unique and very great things about Postgres is that it is flexible and it pushes a lot of the additional functionality outside of the core database into the different tool projects. So when you're choosing your backup tool, you actually have a fair number of choices out there in order to be able to choose from things like pgBackRest to pgBarman to WAL-G and many others. So there's no single way to back up Postgres. Postgres gives you the flexibility to choose the solution that is best for your particular needs. But that requires you to do a little bit of research and understanding the pros and cons of each one of those backup tools in order to be able to choose one that's best for you. So once you choose one, you'll have to install that backup tool on your backup servers. You'll have to configure that. And then you're going to have to set up Postgres in order to be able to enable it for transaction log WAL archiving. So you want to be able to take advantage of some of the great features in Postgres like point-in-time recovery. You need to be able to get the transaction logs every time they switch over, so this way you have the most current version of your database backed up as opposed to just taking nightly snapshots. Then you need to schedule that. Inside of Postgres, usually you're doing that via cron or some other scheduling tool. Within RDS Postgres, that's just an option when you're starting up your instance of when do I want to back up. So this way you set up your backup times and how long are you keeping your backups for. The default is 7 days, but you might want to keep that for 35 days. And this way everything will be automatically backed up for yourself. You don't have to worry about scheduling it. You don't have to worry about configuring Postgres in order to be able to do that. It's just backed up for you, saving yourself a lot of time in setting that up. So once you have the backups, you need to test those backups. No backup is ever valid unless you've actually tested the restore procedure on it as well. So there's been a number of times that we've come across people, out in the field in the Postgres community of people backing up their database in an emergency. They need to be able to restore it, and the backups aren't valid. They have to go roll back to a week or 2 weeks or even a month-old backup in order to be able to get a valid backup. It's because they weren't regularly testing their backups. So you want to make that as part of your normal maintenance routine in order to be able to test your backups. In Postgres, you want to be able to set up another Postgres database on another server, set up your backup tool there, and then run a point-in-time recovery to a specific time. You want to be able to test that you can restore to a specific time. The most common reason that people restore from backups in a real-world scenario is user error. Some administrator thought they were in a development environment, and in reality they were in production, and they accidentally dropped the wrong table. You want to restore from backup in order to get that data back, in order to pull it back into production. It's not because the system failed. It's usually because you just lost a small bit of data that you need to be able to pull back. And you want to restore that to a point in time in order to be able to get it just before that event happened. Within RDS Postgres, you have the option to do a point-in-time recovery right from the console. And when you're restoring it, you don't have to restore it to the same system. You don't have to restore it even to the same exact size of system. You can restore it to a different instance size. So when you're testing your backups, there's no need to restore it to the largest instance size that you may be running. You could run it on a smaller instance in order just to test those backups are valid. Also, you don't need the same amount of IOPS for those tests. Or even when you're trying to restore just that drop table, you could do it in such a way so this way you could do it without spending extra money on your instance sizes. So once you have a database set up you have your backups ready to go, the next thing you need to do is set up for high availability. When you're running for your production database server, you want to be able to set it up in the case of there's a failure on one of your servers. You want it to automatically fail over in order to be able to keep your application running. Again, Postgres with its flexibility, there's no single way of doing that. It really comes down to what's best for you. Do you want to have a shared disk, high availability strategy, or do you want to have replication? Most people out there use inbuilt Postgres replication for that high availability strategy, but some people might have a SAN and they leverage a shared disk strategy. When you're choosing a replication type, you have the choice of whether or not you're going to have synchronous or asynchronous replication. Synchronous means you won't have data loss, but that's at the expense of some performance. Do you want to give up a little performance in order to not lose any data? Most people make the trade that they're going to have asynchronous replication in order to not have the performance hit on synchronous replication. And then Postgres, again, being flexible, it doesn't have inbuilt failure detection. It leverages external projects in order to be able to do that. You're going to leverage what's best for you again. There's Postgres-specific projects like Patroni or other more general purpose projects like Pacemaker that does the failure detection and it'll do the failover for you. By having that as an external project, it allows you to have more flexibility in order to be able to have that failure detection be tailor-made for what you need your production database to do. And then when you have a failover, you need your application to be able to follow that new primary database. So there's, again, a number of different ways of doing that within Postgres, of leveraging tools like HA proxy or having a virtual IP address that follows the new master, or specific tools inside of Postgres called things like pgpool that'll automatically do the failover and follow the new master for you. You need to be able to have your application transparently look at the new database when things have moved to the new server. And then with high availability, you need to test and test and test some more. Again, with RDS Postgres, setting up a multi-AZ configuration gives you the high availability with just a few clicks. It allows you, Postgres will automatically have your data replicated over to another availability zone. And in the event of a failure, which RDS Postgres will automatically detect those failures, it will fail it over to the other availability zone and reroute the DNS entry, so this way your application seamlessly fell over to the new instance. It happens very quickly, and the setup of it happens with just a few clicks inside the RDS console. So once you have a Postgres database that's up, backed up, highly available, now you want to be able to scale it. The common way to do that inside of Postgres is setting up read replicas. So if you have your application that primarily does a lot of reads, or you have a reporting aspect of your application, setting up a read replica allows you to offload a lot of the load off your master database onto one of the replicas. Inside of Postgres, you could do that by setting up, by enabling replication on the master, by setting it in the PostgreSQL.conf file and setting in a number of different parameters there, and also setting up your pghba.conf file to allow replication, the replicas to be able to connect to the master. Then you need to set up Postgres on those replicas. So again, going back to task number 1 of setting up another Postgres database. Then, in order to seed that initial replica, you need to be able to restore a backup from there. So you need to take a new base backup. You may be able to leverage your backup routine that you set up earlier in one of the other tasks, or you could use the utility pg-base backup in order to be able to take a new base backup. And if you have a large number of rows in there, or if you have a multi-terabyte database, this may take some time in order to be able to set up those replicas. Once you have that replica up and ready to go, you need to configure it for replication. So you need to set up your recovery.conf file and again the PostgreSQL.conf file on your replicas in order to be able to start the replication. Inside of RDS Postgres, this happens again through the console with just a few clicks. It allows you to start a read replica and be able to scale your workload very quickly. As you move into Amazon Aurora for Postgres, this happens even quicker because you don't have to take that backup and be able to move it over to the Read Replicas. You're using the shared storage layer. So this way your multi-terabyte database doesn't have to be copied over into another replica. It's all sitting there waiting for it. So this way the amount of time it takes to start up a Read Replica happens very, very quickly. Many people have security requirements, so this way their data has to be encrypted. If you have different security requirements in order to be able to have credit card data or HIPAA data or anything else like that, you need to be able to encrypt your data. Inside of if you're running it yourself, you'd normally use something called LUKS in order to be able to encrypt your database volumes. So you'd install LUKS on your Linux server and then set up an encrypted volume and then move your database into that encrypted volume, which you'll have to worry about things like managing the keys of that and being able to make sure that all your data that you need to be encrypted is on the volume that is the encrypted volume on that server. With RDS, you have the ability to just turn on encryption through the console. So as you're creating your database instance, you're given the option, do you want this volume encrypted? Do you want your database encrypted? And it allows you to pick which keys you want to use, so this way your key management becomes very simple. So this is, you take a task that may take hours, and you're turning it into a few seconds with just a few clicks. So once you have a database that's up, it's highly available, it is scalable, now you want to set it up and you're ready to start monitoring it. You have your application running on there, you want to start monitoring it to decide, is it working well, and be able to predict whether or not there's any problems. Again, Postgres with its flexibility, there's no one way to monitor Postgres. There's a number of different tools out there, from companies like Datadog out to open source projects like Zabbix, pgObserver, or Powwow. Once you choose your tool and being able to leverage what it is, you need to be able to install that on the Postgres database server itself. Usually a lot of them have agents in there that you need to be able to connect to the database. Another thing you have to do is create a monitoring user inside of Postgres. So giving it enough privileges in order to be able to connect to the Postgres database and be able to check the system catalogs and see what's going on inside the database. So you have to create a monitoring user of some sort. Then you have to configure your monitoring tool, and then most importantly, setting up those alerts and deciding on what those thresholds are in order to get alerts. If you're rolling your own with a monitoring tool, a lot of times you have to set up other paging environments or other types of tools in order to be able to get those alerts on your cell phones. RDS Postgres hooks directly in with CloudWatch. So as you're configuring your database server, with just a click, you're able to have your monitoring be right there on your database console itself. So as you're looking at your database instance through the RDS console, you're able to see the different metrics of the database that's going on there. And you're also able to set up CloudWatch alarms in order to be able to get notified if there's a problem going on. In those times when you want to see really what's going on inside the system and see what's going on inside the CPU and understand things where your wait times are, there's also enhanced monitoring. So this way you're able to see those different metrics as low as a 1 second interval. And so this way, if your database is not performing the way you'd expect it to, you're able to look at those individual metrics coming back from the operating system through enhanced monitoring. So once you have a database server that is set up and configured for high availability and scalability, and you're monitoring it in order to be able to see how your application is running against the database, you're invariably going to find a query or two that you want to be able to tune. So when you want to be able to find those particular queries, how do you go about doing that? Inside of Postgres, the normal way that people do that is leveraging a utility called pgBadger. In order to have pgBadger work, you need to be able to turn on additional logging. And then once you get that log file, it's going to log all your queries to your Postgres log file. You're going to download that file onto your client machine and run pgBadger against it. It's going to produce a nice HTML report that'll identify your slow-running queries, your most frequently run queries, and your most expensive queries. That'll allow you to investigate those slow queries, go tune them using Postgres explain plans and other things in order to be able to try to find out how to tune those particular queries that you want to have go faster. Inside an RDS environment, you can take advantage of performance insights. Performance insight can be set up with just a simple click of enabling it. And what it'll do without taking any performance overhead the way you do with the additional logging, it'll automatically collect all your SQL statements that you're running and being able to correlate that against the underlying Postgres wait events. So if you have a particular query that's waiting on I/O or CPU or a particular lock, you're able to identify that very quickly through the UI. You could even go back a day or two if you want to identify a query or a point in time where things were running slower and you want to be able to investigate something after it's happened instead of trying to catch it while it's happening, which is the normal thing that's happening. And inside of your tuning aspect of it, you're a relational database. It's all about the writes to the database. You want to tune those queries for the reports so this way your end users see it. But the relational database is all about collecting that data, whether it's a OLTP application like your sales system or potentially an IoT application as you're collecting sensors of the data. You need to be able to tune your database for that write workload that's coming in. Inside of Postgres, there's a number of different ways to tune that, but the most common areas you're going to be tuning are your checkpoints and your transaction logs. When Postgres is your WAL, your write-ahead logs. So there's a few parameters that you'll tune for that: your checkpoint timeout, your max WAL size, your checkpoint completion target, and all of them act on one another. So as you're tuning one, you may be having other consequences of giving up some recovery time in the event of a failure. So if you tune for maximum write throughput, you might be trading that in the event of a failure, you may take a minute or two in order to be able to recover instead of the seconds that your SLAs require. So when you're working with an environment that requires a high workload or high availability, being able to take advantage of Aurora with Postgres compatibility, you are able to take advantage of the cloud native engine that we've built with write throughput in mind for a relational database. So when Postgres writes its individual transactions out, where it would normally write it out to the disk in a traditional environment, it's written out to the shared storage volume. And it's only writing out your write-ahead logs, your transaction logs. The storage is aware of the Postgres transaction log format in order to be able to reduce the amount of disk I/O out of the main Postgres engine and being able to share that across the storage volumes themselves. So the amount of writes that have to be done is significantly reduced, giving you better throughput in a write-intensive environment. And while you're doing that, you're also getting the high availability of being able to have that across many different storage volumes and across six availability zones. That gives you the very short failover times in the event of some sort of failure. So you don't have to tune for those checkpoints the way you do in a traditional environment. Aurora for Postgres will automatically take care of that for you. So there's hundreds of thousands of customers around the world running Amazon RDS across many different industry verticals, from GE in manufacturing to FINRA and financial services. And today, Amazon Aurora is one of our fastest growing services, so it's something that more and more customers are using every day. If you'd like to learn more, please go to aws.amazon.com/RDS and feel free to try out RDS for free in our free tier.